Hello. Yeah, in this time series using our video, I want to show you how to detect change points in the mean of a time series. Actually, a time series of a continuous variable. Um, so after watching this video, you should be able to detect one or multiple change points in the mean of a continuous time series. Let's get started. Okay, so let me set a random seed, and I'm going to create a time series with a mean shift. So N1 is 100, N2 is 100, and X, you can see the first 100 data points are from a normal distribution with mean 0, standard deviation 1. The second segment is from a normal distribution for mean equal to 3 and standard deviation equal to 1. And then we can plot it out. On the right hand, you can see this is a time series with a mean shift at the location 100. Okay, and the R package I want to show you is the change point, and you have to install it. And the installation is very easy. Just use install.packages double quote change point, and then you load it in, and then you can see the detect change point in the mean, the CPT dot m a mean of x, method equal to pelt, and penalty equal to MBC. Let me take you uh, to the help documentation. Okay, now this is the information of from the documentation of the change point package. It's a comprehensive package. It has change point detection when the mean, change point in the variance, and change point in the regression. So here let's just look at the CPT.mean. So you can see it calculates the optimal positioning and potentially number of change points for data using the user specified method. And the usage, as you can see, the penalty equal to MBIC, or then the pen point value equal to 0, method equal to pelt. So I just want to show you the information about the penalty. You have several choices here: non-SIC, BIC, MBIC, AIC, Hen and Queen, and asymptotic, manual, and crops penalties. I don't have time to really go over the details of each option, so I'm just showing you there's multiple choices here. And the method equal to AMOC or pelt, seg or bin seg. The default is pelt, which is, I'll show you the reference. It's from this paper called the pelt algorithm, published by Killick, Fernhead, and Ackley in 2012, optimal detection of change points with a linear computational cost, published on JASA back in 2012. So the pelt is the default. It has some optimal properties. So since we are focusing on the R implementation, I'm not going into the theoretical details. So if you have interest in change point, do check out the references. Thank you. Okay, now let's get back to R. So let's do the change point detection here. And then we print out the result. You can see the output there. It gave us a bunch of values, told us the information about this changing mean, and we use the pelt method, and the test is the normal, and then we use MBIC with a value. That's MBIC value is 15.89495, and the change point location is the 101. So you can actually really print out the location there, and you can also print out the detected change point. So you can see it marked the means before and after the change point. Okay. All right. So the next part is I want to show you, how do you actually detect the multiple change points. So first you need to load these two library change point and ggplot2. You can set the random seed. Now we get 500 data points, and we build in 3 change points here, the true change points at 100, 250, and 400. Okay. And now we get the means 0, 3, -2, and 5. Okay. And then we build in the segment, and then we generate the time series with the piecewise constant mean and the noises. So you use y assigned as the mu of segment plus a random noise. Okay. And the time index of 1 to n, we put everything into the data frame df, and then we can plot out this time series. And you can see there's the 3 change point. So it's a jump up and then going down and jump up again. Okay. So to detect the multiple change point, we still use the CPT mean function, and the method and penalty. No, method still penalty is BIC, and we can use class equal to true, and then we can find the detected and the change point, and then we can print them out. So it detected 100, 250, and 400. Okay. That's the true change point locations, and the detected ones are 100, 250, and 400. So with this data, simulated time series, the CPT.mean function did a perfect detection. Okay. We can even plot out the detected change point using, put everything into a data frame df2, and we use the ggplot to plot out the different segments, and then we can just print it out. You can look at it. So really very, very closely mimic the true time series we generated. Okay, thanks for watching. This is an example showing you how to use the R-package change point to detect one or multiple change point in the mean of a continuous time series. In my next video, will show you how to detect in the variances of a continuous time series. Thanks for watching.